Hello everyone. Today I will discuss the value of science, education in early years learning experiences, how young children acquire scientific ideas and critical thinking abilities. Children naturally engage with science. Children are inquisitive and investigators, pose queries and try to comprehend how things operate. For instance, they already think scientifically when they construct buildings or playing with water or insects. This demonstrates that science education should be included into regular play experiences rather than being formal. Because of this, science learning should be play based and inquiry driven. When children are given opportunities to explore and experiment, they begin to think deeply and make connections. Research suggests that early learning environments should support children to investigate, problem solve rather than simply receiving information. Providing science experience is important because it builds curiosity, confidence, and persistence. Children learn that it is okay to make mistakes and try again. For example, if a tower falls down, children reflect and use new ideas. They try every idea to make the building up again. This process supports problem solving and resilience. Children also develop important science concepts through hands-on experiences. This includes cause and effects, materials and their properties, force and motions, and change over time. For example, when children explore water and they learn how about floating and sinking to see what happens next, they put objects that are heavy, they put objects that are light to see which objects come up, which goes down, and they become curious to know what will happen next, and they learn through their play. These early experiences from foundation for later scientific understandings. Science learning involves key processes such as observing, questioning, predicting, and testing and reflecting. These processes happen naturally during play. For example, a child may wonder what will happen if I mix water and sand together. And they observe, and the outcome this shows how children is already engaging in a scientific way. Through these experiences, children develop important thinking skills such as critical thinking, reasoning, creativity, and problem solving. These skills are essential not only for science but for lifelong learning. Research also highlights that in today's world, children's thinking is shaped by both physical and digital experiences. This means science learning can extend across different environments. The role of an educator is very important. It supports learning. Educators act as facilitators and ask open ended questions. How this can happen? What will happen next? What can I do? So they can ask open ended questions for children to extend their learning, encourage curiosity, and provide meaningful learning experiences rather than giving answers. They guide children to think, explore, and reflect. This approach supports deeper learning and engagement. Science learning also contacts strongly with belonging, being, and becoming, the early years learning framework, which emphasizes play, exploration, and active participation. It supports children to become confident learners, effective communicators, and active participants in the world. In conclusion, science learning in early childhood is essential because it builds on children's natural curiosity and supports their overall development. Through play and inquiry, children develop important concepts, processes, and thinking skills that will support them throughout their lives. Thank you.
Now let's explore the 5 science concepts. To begin with, Carol will start off with the biological science concept for 0 to 2 years children.
Today I'm going to discuss biology in early childhood, focusing on how infants and toddlers begin to develop biological understanding through sensory-based experiences. I will also describe a developmentally appropriate activity for very young children and explain how intentional teaching supports early scientific learning. Biology is the study of living things and how they grow, change, and interact with their environment. In early childhood education, biological concepts are not taught through formal instruction. Instead, children learn through hands-on experiences with natural world, such as observing plants, seeds, and movement in nature. So these early experiences support children to begin to recognize that living things are changed and can respond to their environment. Research indicates that in the early years, children begin to develop biological understanding through sensory exploration and continuous interaction with natural materials. So, for infants and toddlers, experiences such as observing movement, tracking objects, and listening to simple language foster curiosity and early understanding. Through play and responsive interaction, young children begin to recognize patterns in relationship, which form the foundation of future scientific understanding. Activity to be implemented is called floating seeds and is designed for children from birth to 2 years old of age. So this experience introduces an early biological concept by allowing children to absorb how seeds move through air, reflecting natural process of plant dispersal. The resources required for this activity include dandelion seeds or enclosed glider-like materials that are safe and lightweight, a soft mat or a grassy area, and a natural breeze or gentle airflow from fan, or you can blow it by yourself. These materials are intentionally selected to ensure safety while supporting sensory engagement. To begin the activity, I will establish a calm environment by placing a soft mat indoors or sitting with the child outdoors on the grass. Children will either sit or lie down where they can see it clearly. I will hold the seats or gliders at the child's eye level. Next one is I will gently blow the seeds or allow a light breeze to move them. And children will observe how the seeds float, move slowly, and fall. So I will repeat this action slowly, following the child's interest and engagement as well. So this repetition supports learning by allowing infants and toddlers to focus, observe, and anticipate what will happen next. Throughout the activity, I will narrate using simple repetitive language such as seed flies, up and down, and seed is falling. So this type of language modeling supports early communication, development, and helps children link words to actions. And of course, with the experiences. So this activity is developmentally appropriate for children age 0 to 2 years old for several reasons. They support sensory exploration, visual tracking, which are key developmental skills in infancy. It also encourages observation and repetition and helping children build early understanding through experience. Additionally, the activity introduces early cause and effect learning as children begin to notice that the educator's action caused the seeds to move. The repeated use of simple language further supports early language development. So the intentional and the purposeful teaching is central to this experience. I will intentionally select safe materials, create a calm and uncluttered environment, and model both actions and language. Then responds to children gestures, sounds, and focus, adjusting the activity to meet the individual needs. This responsiveness is essential for effective early science learning. So purposeful inquiry occurs as children explore through watching, reaching, and responding to the movement of the seeds. Although infants and toddlers may not ask questions formally, they are actively investigating through their senses. So this form the inquiry supports early scientific thinking by allowing children to experience biological concepts directly. So in conclusion, this intentional inquiry-based activity not supports sensory development and early scientific thinking, but also promotes meaningful engagement in biological concepts. So through responsive experiences as floating seeds, I can scaffold infants and toddlers' natural curiosity, enabling them to construct foundational understanding of the living world in ways that align with developmental principles of exploration, observation, and of course, hands-on learning. Now, Suhana will talk about the next branch of science.
I will talk about Earth Science. In this assignment, I will present the Earth Science learning experience for children aged 2 to 3 years, which has inspired me from Melbourne Museum. To begin with, Earth Science in early childhood focuses on helping children explore the natural world, including various things like soil, water, rocks, weather, and natural materials. At this age, the children best learn through hands-on sensory play and exploration. So, this experience supports children to develop skills, curiosity, and early scientific thinking. During my visit, I explored how soils is made up of different layers. I then introduced this concept into a play-based and developmentally appropriate experience for toddlers. To show children the soil layers, so we will take a clear container, some soil, some fine sand, and small rocks, and we will add water, leaves, and some scoops. So these are all our materials. To display with the following materials, the main objective of this activity is for the children to explore natural materials like soil, some sand, and some rocks, and to begin to understand that the earth is made up of different materials, I have taken a clear container, as you can see, and there is sand, soil, and small rocks. We will then add water, some leaves, and scoops for children to use, so that each of these materials can represent a simple layer of earth. Together with that, I will also hand the children with their own trays where they can scoop, pour, and build layers using these natural materials. I will support inquiry learning by asking open-ended questions, as these questions encourage children to observe, explore, and think critically. Even at young age, children you can ask them, can you see different layers? Which one feels soft or hard? What happens when we add water? Teaching strategies. The strategies is using simple and descriptive language like top, bottom, soft, and hard. I can also model how to create layers so that they are able to identify it. Scaffold children's learning through guidance and encouragement. Let the children explore freely at their own pace. Furthermore, I will also connect learning into real-life experiences, like allowing the children to dig in the garden so that they are able to see the soil before and after the rain. This activity also supports several important science skills, including observing, exploring, and understanding basic cause and effect relationship. It also promotes sensory development and early environmental awareness. This learning experience links to early years framework, particularly to outcome 2, where children develop a connection with their learners through play-based experiences, and outcome 4, where children become confident and involved learners through play-based experiences, ADGE 2022. It also aligns with the National Quality Standard, especially the Quality Area 1, which focuses on educational programs that support children's learning and development. Overall, this Earth Science experience provides a meaningful and engaging way for toddlers to explore the natural world through play, supporting their curiosity and early scientific thinking. Thank you.
Thank you, Suhana, for the information you provided. It was very helpful and informative. Today, we are going to explore space science and its importance for young children. Space science begins with the introduction of celestial body or space objects such as sun, moon, stars, solar system, sky, comets, and asteroids. As children have a natural curiosity to explore and enjoy the world around them, they develop different aspects through these stimulated and engaging everyday experiences, according to Campbell and others 2024. For example, children begin to name and recognize the aspect of space such as sky, sun, moon, star, space through everyday observations and play experiences. These everyday observations and curiosity helps children to develop the understanding of the world and existence of objects beyond the world, according to Campbell and others 2024. This improves children's skill to inquire, solve problems, and think critically. When children are supported and scaffolded using age and development appropriate experience, they develop space science concept which help them to develop imaginative and critical thinking skill. Moving towards the activity, I have planned for the children of the age group 3 to 4 years, and the experience is known as light and shadow exploration. This experience is associated with space science and will offer opportunities to explore abstract understanding of space and will address the science inquiry skills at the same time, according to the Australian Council for Educational Research 2020. Similarly, through this experience, children will deepen their understanding of natural phenomenon and changes that occurs during everyday life. They will explore how the shadows are formed and will be encouraged to brainstorm the answers. And during these sessions, I will be asking them intentional questions, which includes: Does anyone know why we see shadows or how they are formed? Can we see shadows during night time? What will happen if I turn on the light in the dark room? What will happen if I place the object in front of the light? Will it make any shadow? To extend their knowledge and thinking, children will be encouraged to develop cognitive skills such as exploration, experimentation, questioning, collaboration, and problem solving. For the experience, we are going to use a torchlight. Which will be used as a sun or the source of light, a dark room, and a clear wall, and some of the toys, or we can also use our hands to make different shapes to make the shadows as resources. And to begin this experience, I will invite a small group of children. Okay friends, today we are going to explore something very interesting about the light and space. Can anyone tell me what comes to your mind when I say the word space? Yes, it does mean the object that we can see in the sky. We can see sun, moon, stars, isn't it? Now, can you tell me who have noticed their shadow today? Amazing! Good job everyone! We can see the shadow of most of the object, isn't it? Do anyone know why we can see the shadow and how they are formed? Good try. It is because the object blocks the light, and shadow is formed when the object made up of the opaque materials blocks the light falling on them. It is the type of. Now you must be thinking, what does the opaque object means? It is the type of object that completely blocks the light from entering them and forms the shadow. But I wonder if we can see the shadow at night. Maybe yes. If there is a source of light, even during nighttime, we can see the shadow. Great answer, Pia. We can see the shadow during the daytime because of the sun. To form the shadow, there must be a source of light, and when the light travels in the straight line through the object which are placed in between the source of light, it forms the shadow. And Today we are going to use this torchlight as the source of light. What will happen if I turn on the torchlight in the dark room? Let's try to make shadow. Wow, we can see the shadow over there, isn't it? It is because the object made of this is an opaque object, and it have blocked the light and stopped the light from entering it. That's why we can see the shadow found on the wall, isn't it? Can you make different shapes of shadow? Amazing! I can see lots of shadow on the wall. That was amazing. You guys have used your observations, thought skills, and tested your knowledge and learned so many things about sun, light, and shadow. In conclusion, this space-related experience offered the children the opportunity to build concepts related to the world around them, extend their knowledge and thinking through the use of cognitive skills such as exploration, experimentation, questioning, collaboration, and problem solving. Thank you. Now I would like to pass this presentation to Karen. She will be discussing about chemical science.
That was wonderful. Thanks, Neva.
Chemical science is cornered with understanding the compositions and behavior of substances. This involves the physical and chemical change of matter due to the reaction to another substance. In early childhood settings, when we think of chemical science, the thing that came to our mind are experiments, or it's too complex for them. But have we ever heard or tried to explain to the children about matter? As MacDonald and Rafferty stated, when we are talking about chemical science in early childhood, it is centered around matter. Hi, my name is Karen, and I will be discussing chemical science. To explain the concept, let's try to understand what is matter. It is everything around us. It is the air we breathe, the water we drink, the phone you are using, and our own bodies. Matter is anything that occupies space and has mass, which means that everything you can touch, you could feel, taste, smell, and interact with is a matter. For young children, it starts through exploration, and as Campbell and Howitt stated, through these experiments, their science cognition further develops. They learn by touching, tasting, mixing, and observing, hence helping them to notice that different materials have different properties. We are going to explore one state of matter, which is liquid. To support this learning, I have prepared a clear container, honey, oil, and water, which is I added food coloring, which is optional. In this activity, we will be exploring how different liquids behave when they are combined. To begin, I have our different types of liquid. Let's observe and notice the difference between these three substances. Do you think the honey looks so thick and sticky? The oil feels slippery and smooth. The water looks runny and clear. Can you see? I wonder, what do you think will happen if we combine these substances together? Will they mix or stay separated? The emphasis in this activity is on supporting children to develop their inquiry skills to describe what they observe when trying to mix these liquids. Through this activity, it will help them understand why some liquids do not mix. First, we pour our honey into the clear container. Let's watch carefully. What do you notice? Yes, the honey sinks straight to the bottom. It moves very slowly because it's thick and heavy. Next, we add the water. What do you see? The water sits on top of the honey instead of mixing with it. That's interesting. Why do you think that is? Now let's add the oil. Watch closely what is happening. The oil floats right on top. Now we can see three different layers. Why do you think they are staying in layers instead of mixing up together? We have honey, water, and oil. Even though all of these are liquids, they are different. Some liquids are heavier and some are lighter. The heavier liquid sinks to the bottom and the lighter one floats on top. The honey is the heaviest, so it stays at the bottom. The water is in the middle and the oil is the lightest, so it flows to the top. This is due to their density. Density refers to the relative weight of the objects, or in this state, substance. Honey has high density and oil has a low density. Through this activity, children begin to understand that all materials are made of matter. They have different properties. Even liquids can behave differently, and some substances sink, float, or stay separated. In conclusion, chemical science in early childhood is about helping children to explore and make sense of materials around them. Through simple hands-on experiences, like the oil, water, and honey experiment we just did, children will develop early scientific understanding, curiosity, and confidence in their thinking. Thank you so much.
Hello everyone. Today I will be exploring what physical science is and why it is important in early childhood education. Physical science emphasizes supporting children in understanding and interpreting the physical world through hands-on experience and investigation. So physical science incorporates fundamental concepts including cause and effect, movement and force, gravity, magnetism, and energy. These concepts are not only part of formal scientific education, but are also present in children's daily experiences, such as pushing objects, using tools, or observing how things move. So, young children improve their understanding of physical science through active exploration, enabling them to perform activities, observe outcomes, and experience immediate effects. This underscores the importance of play-based, inquiry-driven learning, where children are encouraged to experiment with ideas, engage with materials, and observe patterns. Although young children may not fully understand of scientific ideas theoretically, they can effectively interact with these concepts through concrete, hands-on experiences, therefore allowing opportunities to experimentation such as exploring magnetism, develops scientific thinking, and helps in building fundamental knowledge of physical world. So moving forward to the activity that I have planned for children aged 5 to 6 is called Magnet Discovery. And this activity is linked to physical science, where children explore concept of magnetism through hands-on experience. Physical science is in early years supports children understanding of the physical world through concrete concepts include cause and effect, movement and force, and magnetism. So for this activity, we need magnets and different objects like keys, spoons, plastic toys, wooden blocks, fabric pieces, pen, paper clips, and papers. So to begin this experience, I invite small group of children to introduce magnets, explaining that magnets have special invisible force. So then I encourage the children to make prediction about which objects they think stick to the magnet, or I will ask some intentional questions such as, do you think this will stick? Or why do some objects stick and why others don't? And children sort the objects into two groups, so which is magnetic and non-magnetic. So these materials help children explore which objects are magnetic and which are not. Through this activity, children discover the magnets can attract certain objects while avoiding others. So children will develop their skills such as exploration, experimentation, and questioning and problem solving to their learning. So also this experience links to EYLF outcome 4. Children are confident and involved learners, and outcome 5. Children are effective communicators. So overall, this activity supports children's exploration of magnetism through hands-on experience and active investigation. It encourages children to think, ask questions, and make connections regarding physical world. So this experience fosters early scientific skills in young children and enhance their confidence in discovering and understanding how things work. Thank you.
Thank you everyone for watching and engaging in our video. We hope this presentation and video have shown how science can be introduced in meaningful and age-appropriate and engaging way in early childhood education.